Today we're doing Chapter 1, Section 5, Analyzing Graphs of Functions. Find the domain and the range of each graph. Let's look at our first graph. We're looking for the domain, so we're going to go along the x-axis. And as we go along the x-axis, we see that the function exists everywhere. So we write that as the domain of negative infinity to positive infinity. Now, looking at the range, we start at the bottom and go to the top, always looking at our smaller number first. And as we look at our range on our function, we see that it's restricted from negative 4 to positive 4. So we write our range as negative 4 to positive 4, using brackets to indicate that we're including both the negative 4 and the positive 4. So there's our domain and range. Now let's look at the second graph. It looks a little bit different. It does have the hump in it just like the previous graph, but it doesn't go back up. So as we're looking at the domain, as we go from left to right, we see that the domain or the function exists everywhere. So again, we have the domain of negative infinity to positive infinity. Again, we always write the smaller number first. Okay, now our range, as we look at our range, we start at the bottom and go up. We see that it continues going negative, but it is restricted at the top at 4. Now, some of you might want to go ahead and write 4 as the first number in our range, but 4 is not the first number because it is not the smaller number. The smaller number is negative infinity. 4 is the larger number, and that's where the function stops. And again, we use a bracket to include that it is the end of the function. Now we want to find function values of a given graph. We're looking for f of 0, and we want to find out what the y value is at f of 0. Well, f of 0 is where x is 0, right here. Well, we notice if we're right there that our y value is also 0. So f of 0 equals 0. Now, if we do f of x equals 1.5, that's right here. And we want to know what the y value is right there. So we go up until we hit the graph, and we see at 4 is where f of x is 1.5, y is 4. Okay, now let's look at our second graph. We're looking at f of 0, which is here. We follow it up until it hits the graph, and it hits the graph up here at 4. So f of 0 equals 4. Okay, then we do f of negative 2. Well, this time we don't go up because the function doesn't exist up, but it does exist down. And we go until we hit the function, which is here at negative 4. Next, we're looking at the simple concept of the vertical line test, which means if I can draw a vertical line and it cuts through my graph in more than one place, then it is not a function. As we can see with our first one, the circle, there are many places where I can draw vertical lines, and it hits the graph more than one place. Okay, let's look at our second graph. If we do our vertical line test with it, we see every time I draw a vertical line, it only hits the graph once. Therefore, the second graph is a function. The first graph is not a function. We want to find the zeros algebraically in a function. To do that, if we have a trinomial, as in problem number 1, we need to factor. And if we factor this, it factors as x plus 8 times 2x minus 3. And we set that equal to 0 because we're looking for zeros. Okay, we solve each one of the factors separately, so that's x plus 8 equals 0, and 2x minus 3 equals 0. I subtract 8, and x equals negative 8. I add 3 over here, and 2x equals 3, divide by 2, and x equals 3 halves. So my two zeros are negative 8 and 3 halves. Now, looking at our second problem, we see that it's a cubic. Well, we also notice that we have an x that's in common. So the first thing I want to do is factor out an x. So that's x times 1/2 x squared minus 1, and we know we're setting it all equal to 0. So I already know I have one factor, x equals 0. Now I need to work on my other factor, 1/2 x squared minus 1 equals 0. Well, I go ahead and add 1 to both sides, and I have 1/2 x squared equals 1. I multiply both sides by 2 to get rid of the fraction, and I get x squared equals 2. Now I need to get rid of the square root. To do that, I do the square root of both sides, and I get x equals, and don't forget, anytime you take a square root, you have a plus or minus root. So I have plus or minus the square root of 2. So that gives me my solutions as 0 and plus or minus the square root of 2. Increasing and decreasing and constant parts of functions. We notice our function from here to here is decreasing. And we write that interval as -2 to 1. And from here to here, we see that the function is constant. So we write that as 1 to 2. And we notice from here all the way out here to 4, our function is increasing. And we write that as now, if we want to write the whole interval, we would just add in the union signs to say that those were all union together and put together to make the entire function. We want to use the graph shown to describe the increasing or decreasing behavior of the function over the interval from -4 to 4. Okay, that means we're looking only at our graph from here to here. Okay. We notice at the interval from -4 to 1.5, -1.5, our function is decreasing. We know from 1.5, -1.5 to 1.5, it's increasing. And then we know our last interval from 1.5 to 4, it is decreasing. Okay, It's slides like this. If you need to pause so you can copy everything down, pause so you can copy everything down. Test for even and odd functions. A function y is equal to f of x is even if for each x in the domain of f of negative x equals f of x. A function y equals f of x is odd if for each x in the domain of f of negative x equals to negative f of x. We want to determine whether the function is even, odd, or neither. Then describe the symmetry. Okay, so first we do g of negative x is equal to negative x cubed minus negative x. Well, that gives me negative x cubed plus x. And that's odd. And it is symmetric about the origin. If you have any questions about why it was odd or even, look at the previous slide. Our next function, h of x, is equal to x squared plus 1. We're going to do the same thing. H of negative x equals negative x squared plus 1. Well, this is going to be equal to x squared plus 1, which is the original equation, which means it's even. And it is symmetric about the y-axis. Okay. Again, if you have a question about even or odd, you can check the previous slide. Thank you. And to show you graphically why they are symmetric about the axis, we have the graphs graphed out for you. G of x is equal to x cubed minus x, which means if I have the line that goes through here, and it reflects, then that means it's over the origin. Okay, if I have a line here where I have 2 points that reflect on a horizontal line, then I have the y symmetry.